In this video, we're going to sketch secant and cosecant functions. And so the process is going to be very similar to what we did to sketch tangent and cotangent functions, except we're just going to be starting from the base definition of secant and cosecant, which we talked about in the previous video. So, okay, here we've got a transformed secant function. It hasn't been shifted horizontally or vertically, but it's been scaled by a factor of 4 about the x-axis. And so we know that the period of secant and cosecant is 2 pi instead of pi. For with tangent and cotangent, it was pi. So we go from period 2 pi to period 8 pi. Right? 2 pi times 4 is 8 pi. Now with secant, the period goes from, it's like from a little bit on the left side of the y-axis and some portion to the right on the right side. It's 3/4 of the period is in the positive direction and 1/4 of it is in the negative direction. That's the standard base period that we're going to sketch, and then just copy and paste that up and down the graph. Now, okay, but is this interval shifted? Well, there's no shifting here. So, all right. So 1/4 of 8 pi is 2 pi. So let's see, 1, 2, 3, 4, 5. We'll do this. Minus 2 pi. And then 1, 2, 3, 4, 5. There's 2 pi. 1, 2, 3, 4, 5. 4 pi. All right, so yeah. 1, 2, 3, 4, 5. 6 pi. So let's see. Yeah, it's going to go from minus 2 pi to 6 pi. That's 8 pi. 3/4 of it is on to the right of the origin, and 1/4 of it is to the left. Okay, and then we've got vertical asymptotes, if we think about the secant function, and cosecant really, but secant and cosecant are just shifted relative to each other. So we're going to have a vertical asymptote here, and then we'll have another vertical asymptote at 2 pi, and then another one at 6 pi. Okay, now let's see. This has been scaled up about the y-axis by a factor of 3. So those local minimum and maximum points are going to be at, instead of 1 and -1, they're going to be at 3 and -3. So we can still do, let's see, we could do 5 to -5. All right, now there's no flipping, so we know that this is going to be up here and this is going to be down here. All right, now the local minimum here is going to be at 3. 1, 2, 3. And then here, and it's in the center of the interval, and then in the center of the interval here, 1, 2, 3. All right, now, you know, that's enough to draw the curve. I mean, we could, you know, but I guess it'd be good to plug in some quarter points in each of these intervals just to help us with the shape. So let's see. Plugging in minus pi, so secant of minus pi over 4. Is root 2 times 3. So, okay, this is, so 3 root 2 is what? 4.24. So, okay, minus pi, and then 1, 2, 3, 4, 4.5. So there's about 4.24. Now this is, it's symmetric, so we can just do like this. And then it's like the same shape down here. So this was what? 2.5 tick marks. So we'll do 1, 2, 2.5, Okay, now we can draw the curve. So this is like a local minimum, and it's, I probably should have brought this point down a little bit more so we could see the graph better. It's probably more like, let's see, maybe like that. Okay. So there we go. Now let's copy this. And there's the graph. Now, also remember, it's interesting to keep in mind how, so with secant, the reciprocal of secant is cosine. And we know that secant and cosine are equal at the amplitude points of the cosine and at the local minimum and maximums of the secant. So, if you're ever drawing a secant curve like this, or cosecant, like it's the same idea with cosecant and sine, or if you're graphing it or whatever, then you could always we could put a cosine curve with the same period and amplitude, and even if it's shifting, like the same transformations applied to the cosine curve in between here, and it would touch it would look like this. So it would have period 8 pi and amplitude 3. So let's see, it would go dip through here and come, so it would do this. It would cross over here, do like that, and then cross over here and do like that. All right, so this would be y is equal to 3 cosine 1/4 x. Amplitude 3 period 8 pi, right? It goes a 1 full cycle in 8 pi. So it's pretty cool to note that as well. Okay, so here we're going to have cosecant shifted to the right pi over 2, not scaled about the x-axis, and scaled down about the y-axis by 1/2, and also flipped about the x-axis. All right, so we know that standard just cosecant unshifted or untransformed has period 2 pi, and it goes from like, so 1, 2, 3, 4, 5. If that's pi and that's 2 pi, then it's like that. That's a period, okay? Now the period hasn't changed here, so we can still do, let's do 1, 2, 3, 4, 5. This will be pi, 2 pi, okay? Now, but it's going to be flipped though, so it's going to be, if you just flipped, it would be like we're going to have like this instead. But it is going to be shifted though as well. So, okay, let's shift the asymptotes. The period's going to be 2 pi, but let's shift the asymptotes. So we're going to be going to the left pi over 2. So here's the first vertical asymptote. Okay, now the end of the period is going to be here. It's still 2 pi. Okay, now we need to put in the middle, let's see. So we need to go 2.5. So this is the middle. That's at so that's pi over 2. It's minus pi over 2, and then what is this? 3 pi over 2. Okay, so now we're going to be scaled. We can still do, let's do 5 to minus 5. Okay, so we would typically, without any flipping, we'd be something like this, but we're going to flip. So it's going to be the opposite of that. Flip about the x-axis, it's going to be like this. Okay, now it's scaled about by 1/2 about the y-axis. So instead of being at the local minimum and maximum being at 1/2 and minus 1/2, or 1 and minus 1, we're going to be at 1/2 and minus 1/2. So that's here and here. It's at the middle of the interval. Okay, now we can plug in. Let's plug in minus pi over 5. Or we could do pi over 5. That's fine too. That'd be easier. So pi over 5 plus pi over 2, that's 2 pi over 10 plus 5 pi over 10. That's 7 pi over 10. So cosecant of 7 pi over 10 is what? $1.24. So now divided by 2, and then so minus 0.62. So this is x equals pi over 5. So minus 0.5, then minus 0.75. So right in there. Okay. So actually, let's change the scale here. We'll do 2 to minus 2. So we've got 0.2, 0.4, 0.6. So, okay, there's minus 0.5. And then there's 0.5. And then we've got minus 0.62. So that would be 0.2, 0.4, 0.6, 0.7. So like right in there. A little past like a little bit past a half a tick mark from the local maximum here. Same idea, a little bit past, okay, what are we, past the center, so like that. So we've got okay. And there we go. So now let's copy this. Okay, there you go. And so, but again, we can draw, so the reciprocal of cosecant is sine, we could do minus 1/2 sine of x plus pi over 2, and that would be like this. And this has the same period, so we can see the period is 2 pi. It's been flipped, right? Look, it's starting at the negative amplitude, but this looks like a cosine, right? Well, that's because of the shift. If we shifted this back pi over 2, we're starting it at a negative sign. Okay, cosecant shifted to the right pi over 4. So the period doesn't change. It's not. It's the pure shift of cosecant. So we know cosecant, the period is 2 pi, and that period's going to go. The one we're going to draw is going to go from here out 2 pi. So let's do 1, 2, 3, 4, 5. Okay, let's draw the asymptotes. So we'll have an asymptote here at x is equal to pi, vertical asymptote. We'll have one at 2 pi, and then we'll have one at x is equal to 0. That's the standard cosecant. Okay. Oh, well, no, I'm sorry. That's incorrect because it's shifted pi over 4 to the right. So this is pi over 2. So that's 2.5 tick marks. So 1 1/4 tick mark is going to be where we're going to start. That's pi over 4. And then the next tick mark would be at pi, but we're going to shift 1 1/4 tick mark over. Okay, and then typically the final asymptote would be at 2 pi, but we're going to shift over pi over 4. There we go. Okay, and let's see. We can go from 5 to minus 5. All right, now before it was shifted, the middle between these two vertical asymptotes would have been here at 2.5 tick marks. So let's go over at 1 1/4 tick marks. That's the middle, and we're going to be at 1 here. Okay, now same idea here. There's 2.5 tick marks go over 1.5, and we're going to be at minus 1 here because there's no flipping, right? It's just a pure shift of cosecant. All right, now we can just plug in like cosecant of, let's see, between 0 and pi. We could plug in cosecant of pi over 4, and that's going to be the same height. Whatever the unshifted cosecant at the quarter point, it's going to be the same height. So just to make it easy, let's plug in cosecant pi over 4, right? If we think about cosecant unshifted, so it would be like here. Well, we're trying to get this height here to get one of the quarter points. Well, instead of plugging in, cosecant pi over 4 plus or taking into account the shift, let's just make it easy and plug in the unshifted cosecant. So cosecant pi over 4 is root 2, which is 1 point, what is that? Yeah, 1.41. Okay. So, all right, each tick mark is a half. Let's see. So that's the middle. So then 1.41, there's 1, there's 1.5. So like right in here. So almost like something like that. Okay. So we go about 3/4 of the way down. So like that. And there we go. like that. Okay, and then we could draw the reciprocal of cosecant is sine, so sine of x minus pi over 4, and it would look like this. There we go. All right, secant, but shifted to the left pi over 4. No other transformations. So let's do, okay, 1, 2, 3, 4, 5. Okay, and then we'll do 5. Okay, so secant, so that the main period would normally go from minus pi over 2 to 3 pi over 2, but we're shifting to the left pi over 4, so halfway between the origin and the first major tick mark. So let's put, all right, now we go, let's see, pi over 4 in this direction here. Okay, now let's, at the midway point, we have another, let's see, that would be where? Or wait, no, I did this wrong. We would do, secant would normally be from, I said minus pi over 2 to 3 pi over 2, so we want to shift to the left pi over 4, which is 2.5 tick marks. So we're going to be here. Okay. And all right, now this would be halfway normally, so we go 2.5 tick marks like that. There we go. Yes, the period hasn't changed. Nothing's changed except it's just a pure shift to the left. Okay, now at the halfway point, but in these two intervals, we're going to be at 1 and minus 1, but in the halfway point, at 1 and minus 1 over here. So, okay, where's the halfway point? Well, typically it would have been, before the shift, it would have been here. Hold on, is this right? Okay, no, before the shift, it would have been at the center, at the origin. Now we've shifted it 2.5 units, so now we're here. So, all right, and then before the shift, the midway point would have been here. Now we need to go 2.5 tick marks, and now we're here. There's the local minimum, and then the local maximum's here. All right, now let's plug in. We can plug in points into the unshifted secant to make it easy. So our unshifted secant's going from minus pi over 2 to pi over 2. Let's plug in pi over 4. So secant pi over 4 is root 2. It was at 1.41. Yeah. So at the quarter and 3/4 points, we're going to be at 1.41-ish. So this is 1, this is 1.5, so right in this region. Now, where's the quarter point? Okay, typically that would have been at the, so we're going from minus pi over 2 to pi over 2. The quarter point would have been here. So we're going to have a quarter point here at the origin. So let's see. All right, and then we'll have a quarter point here. All right, now, yeah, this will be a quarter point for this interval. So how we went about to there, and then there we go. So all right. Like that. Okay, let's copy this. Okay, there we go. Now we can add in y is equal to cosine of x plus pi over 4. And that would look like, so like that.